y'all, it's Miss Power here, with another module review for the test. um, your review day is on Tuesday, so tomorrow on the 18th. Your test is on Wednesday, so 2 days from now on the 19th. I'm going to print this out. We're going to go over it tomorrow. You're going to ask questions as if you were taking the test. And then on the actual test, you're going to ask fewer questions because you've already asked them on Tuesday. Here's the video of me going through the review just by myself, and then we can talk more on in class on Tuesday, or before school on Tuesday, after school on Tuesday, or before school on Wednesday. All also options. All right, let's get it. For number one, you surveyed the grades kindergarten through second grade and third through fifth grade over at Washington Elementary School to find out whether they liked summer or winter better. Here are the results. They give it to you in Venn diagram form. Let's remember what all these mean. K through 2, so everything in this orange circle is kindergartners through second graders. And then everything out of this circle, so the green stuff, is third through fifth graders. And then everything in the blue circle is summer. So these two numbers are summer. And then everything underlined in purple must then be winter. Cool. So when we create a two-way table, summer is the thing in both, K through 2 summer is the thing in both of the circles, the 212, because it's in the, it's underlined in orange and blue. It's in the orange row and the blue column. Summer 3 through 5, summer is split into two things. It's the stuff that's K through 2 and the stuff that's not K through 2. So this is the part that's not K through 2, but is summer. All right, for winter K through 2, we want the stuff that's in the K through 2 circle, but outside of the summer circle. So that's the 180. And then the leftover is the leftover number, right? Shoot. We can also think of this as 134 is outside of K through 2, so it has to be 3 through 5. And it's outside of winter. It's outside of the summer circle, so it has to be winter. Another thing to know is that none of these numbers are total. These numbers are totals, right? All of the numbers in the Venn diagram are these specific broken down numbers. They go right here. And then we have to fill in the totals ourselves by doing some addition. So the 4 numbers you see in the Venn diagram go in these first 4 spaces in the two-way table. And then we create the totals by adding numbers together. So let's find this number by doing 212 plus 180. We find this number by adding these two numbers together. That is... We find this number by adding these two numbers together. And you'll have a calculator on your test, or you can do it in your head, either way. This number is adding these two numbers together. That seems like it'll be 14. And then this number, we can either add these two together, or we can add these two together. It should give us the same number. And if it doesn't, we should be a little bit concerned. So let's see if this did it. 32, perfect. Cool. That's the way to go from a Venn diagram to a two-way table, is we write in these first 4 numbers and then add up all the totals. In order to go from this to a tree diagram, we can either do the two-way table first and then go over, or we can put these over here. The main thing for the tree diagram is we have to decide first, are we splitting them into people that like summer and winter and then splitting them into the age groups, or are we going to do the age groups first and then summer and winter? Either way works, but the first step should basically be one of these things, and then the second step should be the next pair. I'm going to make my first pair be age. There are 392 total K through 2 students and 540 total 3rd through 5th graders. I could have gotten that from this part of the 2A table, or I could have added up these two numbers and gotten 392, and added up these two numbers and gotten 540. So if I want to do the tree first, I'm allowed. Okay, once I broke them up into one category, age, now I'm going to break them up into the second category, season. So each of these have a summer and a winter option. And this is where I say, okay, this first number is K through 2 people who like summer. Again, I can say that's K through 2 people that like summer from the 2A table, or the number that's both in K through 2 and summer. K through 2 that likes winter is either the people in K through 2 that's outside of summer, or I can find it on the 2A table. 3rd through 5th who like summer is 406. And 3 through 5th who like winter is 134. Again, these numbers, let me get a better color. These numbers, and the numbers in the Venn diagram are all the same numbers, right? The final breakdown. One way to know that you've done it right. Cool. Now you've got all 3 representations. We're going to do some probabilities, and you can decide which one you like looking at best. I like looking at the 2A table best, so I'm going to use the 2A table, but you can use whichever one you want. So when it says find the following probabilities, this is the probability that we're from 3 through 5. This one's the probability that you're in K through 2 and in winter. This is the probability that you're in summer, given that you're in 3 through 5. This is just the probability that you like winter, the probability that you are in K through 2 or like summer, and the probability that you're in K through 2, this should be a 2, given that you like winter. All right, the first things I'm going to note. These ones have different totals because they're conditional. And that means they have the bar, right? So immediately, I'm going to figure out what these denominators are before I even kind of figure out what the whole fraction is. The back number gives me the total. So if I want the probability that someone likes summer, given that they're in grades 3 through 5, my total is 540 because they're for sure in grades 3 through 5. Whereas this bottom one says, what's the probability that you're in kindergarten through 2nd grade, given that you like the winter? So the only thing that I really know about them is for sure is that they like the winter, which means they're one of these 314 children who likes winter. Great. I'm now going to fill in the totals for the rest of them. And anything without a bar, any single probability that's not a conditional probability, will be out of the actual total number of students we talked to, right? This is the overall total. And this is going to be the denominator for everything that's not a conditional probability. All right. Now that I've figured out my probabilities, now I'm going to go ahead and fill in with the rest of the things. Or the denominators. Now I'm going to fill in the rest of the probabilities. So the probability that you're in 3rd through 5th, it has no mention, doesn't mention seasons, right? It doesn't say anything about summer or winter, so it wants all. It wants all 3rd through 5th graders. So it wants all 540 3rd through 5th graders. The total. This one down here doesn't mention grades, doesn't mention age, so it wants all winter people. The total number of people that like winter. All right. And is the one where you only get one box. If we do the probability that we're in K through 2, so we're in this row, and we're in the winter column, there's only one number that's in both, and that's 180. When we're looking for and, we're looking for the thing that's in both, and 180 is in both K through 2 and in winter. And the last one is K through 2 or in summer. These are all the things that are in summer. These are all the things that are in K through 2. So we're actually going to add those three numbers up. We're going to say 212 plus 180 plus 406. And then that number is, get my calculator out real fast, 932 minus 1 is, where's my pen? 798. We talked about a few tips and tricks for how to add those numbers fast, right? You can do the total plus the other one. You can do the two totals, but then you subtract out this because you added it twice. You can just add these three numbers up, just regular in a calculator. You can take this total and subtract out this number because it's the only one you don't want. There's a lot of different ways to do it, but whichever way means you're getting those three numbers added together, that's perfect. Now, we're going to go do the conditional ones, which is saying once you change the total, so change total for conditional, and then we'll just do the same thing we did for and, right? We want summer and 3 through 5. So it's under summer and it's under 3 through 5. So the numerator is summer and 3 through 5. The denominator, where we do this, just the 3 through 5 people. So K through 2 and winter is 180, and it's slightly different than number 2 because the denominators are different. And that's number 1. All right, moving on to number 2. Now, instead of giving us a Venn diagram and having to fill out the rest of the stuff, they're going to give us a two-way table, and we need to finish this up. The way we finish out a two-way table is we know that these two things add to the total, right? Any column adds to its total. Any row adds to its total. So we find a row or a column where there's two things filled in. And we say that this one is 124 minus 10. So this one should be 114. Then this total is 114 plus 136, or plus 36. So that's 150. That seems kind of right. Let me do that. And now we've got more that have 2, right? This one can be 258 minus 124. Set the one in the other blue. That seems good. This one is 134 minus 36, which is 98. Is that true? Yes. And then this one is 98 plus 10, which is 108. So the main thing when filling out the two-way table is you find a row or a column that has two of them, and then you solve for the last one by knowing that the first two numbers added together equal the third number. All right, and now we've got our data, so now we can do some probabilities. We want to write, I'm going to write the probabilities my way, and then we're going to solve them. So the probability of someone buying a softball, up here, we said the conditional thing, so with the bar, gives you a different total. Over here, the phrase given that is going to mean a different total. Different total. So let's watch out for that. The probability of someone buying a softball should be over 258 because that's the overall total. And then the total number of softballs is 150. We didn't talk about the color of the ball yet, so we don't want to include these like sub things in our probability. Same for this one. What's the probability of someone buying a white ball? It doesn't say whether it's a baseball or a softball, so we just want to do total white balls over complete total because we didn't see given that anywhere. All right, what is the probability of someone buying a white ball given that they bought a softball? This is where the given that stuff comes in, right? The softball is the thing we know happened. So the total softballs is going to become our denominator. And now the numerator is just saying how many white softballs are there. And there are 36 white softballs. Cool. What's the probability of someone buying a baseball given that they bought a white ball? This is when we change the total. White balls go on the bottom. We're going to scroll up. There are 134 white balls. Then how many baseballs are white? 98 of them are white. So because there's 98 things that are white and baseball, that goes in the numerator. And the denominator is not 258 because we've seen given that, and that means it's a conditional probability. So that's this. Given that changes the total. Given that changes the total. All right, what's the probability of someone buying a softball or a yellow ball? Total is definitely going to be over 258 because that's the overall total. Softball or yellow. These are the softballs. These are the yellow balls. We want to add those three numbers up. 10 plus 34, 36 plus 114. And that number is 160. We don't have to simplify past that. And then what's the probability of someone buying a baseball and a yellow ball? It's over 258. We didn't say given that, there's no bar, so we use the overall total. And then the baseball and yellow, there's only 10 things that are baseballs and yellow. So we put 10 here. And now we want to check, is buying a white ball independent of buying a baseball? And we're going to explain using this following equation. If it turns out that the probability of buying a white ball times the probability of buying a baseball is equal to the probability of buying a white and baseball, then they're independent. If it's not, then they're dependent. So let's check it out. The probability of buying a white ball is 134 over 258. 134 over 258. I got this because there's 134 total white balls and 258 total balls. Probability of buying a baseball is also over 258. Spoilers. This one's also over 258. Right. Total number of baseballs is 108. And then white and baseball up here is 98. So we're going to see if these are equal. This side as a decimal, let's get my calculator out. 134 times 108 divided by 258 divided by 258 is like 21.7%. This side, 98, 258, is 37.9%. Turns out these are not equal. So these are dependent. D-E-P-E-E. Dependent. Because these numbers are not equal. If these numbers were equal, these would be independent. Cool. Using the table in number 2, shade in the following Venn diagrams to illustrate the probability statement. So we can basically do this without the table, actually. I'll change that wording. Here we're going to do the thing we did, I think it was page 11 and 12. It was like Fried Freddy's or something. Where we're just going to shade in the parts of the Venn diagram that we're talking about. So here we're asking, what's the probability that you get a baseball rather than a softball? Baseballs are this moon shape and this middle shape. Right? It's everything inside of the baseball circle. If we jump over to part D, if we're asking for balls that are not white, right? This is a white one, and this is a white one. We want everything that's not white. So it's the baseballs that aren't white, and it's all this outer stuff. It's everything that's not inside the circle labeled white. Okay? This one is asking for softballs and yellow. And this means we're only going to fill in one shape, because and means it has to be both. It's not baseballs. It's not white. So it turns out it's this outside shape. And then this one is an or. And that means we're going to fill in 3 of these shapes. We want baseballs, so we're going to fill in every single baseball shape. It's basically just part A again. Then we're also going to fill in the yellow shapes, so the things that aren't white. So that's this outside one. And it's hilariously this one on the left again. It doesn't matter if it's filled in twice or just once, it counts for the or. So basically we only don't want this one. We only want the things that aren't baseballs. We only don't want the things that aren't baseballs and aren't yellow. All right, that's number 3. Then last one, but many parts, of course, because it's a math test. 9th and 10th graders were surveyed after winter break, and they were asked what grade they're in and whether they spent time during break studying for their math or their science exam. A Venn diagram has been created below. We're going to use the Venn diagram to fill out the other representations and answer the questions. So again, we're given a Venn diagram, and we want to port this over here. These 4 numbers, where do they show up? They show up over here, and they show up in these 4 spaces. So we should expect these 4 numbers to show up in all 3 of our representations. All right, the 350 are the 9th graders and the mathematicians. So 9th grade is 9th grade math 350. These 200 students are 9th graders, so they belong here, but they're not in math. So they belong here. And that's why these 200 people are going to be 9th grade science. These 300 people are math, are not 9th grade. So they must have been 10th grade maths. And this 400 is not math and is not 9th graders. So they must have been 10th grade science. Now that we have these filled in, we're going to add all of these rows and columns together. And both of them equal 1250, which means we did a good job. When we did the tree diagram, the test is already split up into ninth graders, so this one must be 10th graders. And the 550 is the total for ninth graders, so we want to put the total for 10th graders here. Then we want to further split these into math and science, math and science. Because we had already used these designations, so now we want to use these ones. Ninth graders who are into math is 350. Ninth graders into science is 200. 10th graders into math is 300. And 10th graders into science is 400. Again, these four numbers showing up all over the place. And then this shouldn't surprise us. We're going to do some probabilities. Right? For these ones, it says, translate the following questions into a probability statement using the proper notation, and find the probability. So we also want to do these P statements. Right, so let me write these in. Okay, what is the probability that a randomly selected student studied math? Because we didn't say anything about their age, we're just going to write M. What's the probability that a randomly selected student was in the 9th grade or studied science? And we do want to use this symbol for or. What's the probability that a randomly selected student was in the 9th grade and studied math? And we want to use this intersection for and. What's the probability that a randomly selected student was in the 9th grade, given that, that's the bar, they studied science? And then I'm going to make each of these a fraction, and my setup will be complete. And now I want to do the actual probabilities. So before I even started on these ones, I wrote my little sentences in the math speak, and then I made sure to notice these are all going to be fractions. All right. What's the probability that a randomly selected student studied math? There is no bar, so it's going to be out of 1250. And the total math people are 650. I know I'm going with total math because it didn't say anything about your age group, right? I don't want the 9th graders or the 10th graders. I just want everyone who likes math, the total of people who like math. What's the probability that a randomly selected student was in the 9th grade or studied science? Or means we're going to add three things together. So it's all the 9th graders, all the scientists. We're going to add those together. It's going to be 350 plus 200 plus 400 out of 1250. Out of 1250, because there's no bar, there's no given that. So this one's 1250. This one is 679. 950. Nice. This one says, what's the probability that a randomly selected student was in the 9th grade? Well, let me go back here. Or means add three things together. And means there's just going to be one thing. One little cell. Okay, if we want 9th graders and mathematicians, we want the people that are in 9th grade and in math, so we just want this 350 number. And then what's on the denominator? There's no conditional statement, there's no given that, so we just are going to use this 1250 number. All right, last one. What is the probability that a randomly selected student was in the 9th grade, given that they studied science? The given that changes the total into the science total. Oops. So again, this tells me I need science total on bottom. And this tells me I need 9th and science on top. So who's in ninth grade and studied science? There's 200 of them. So this is going to be 200 over 600. All right, y'all, that's basically the test. Of course, I'll change the numbers, and of course, I'll ask for slightly different things. But if you're able to do this review, I think you have a pretty good chance of acing this test. So watch this video, come by either before or after school, ask your questions on Tuesday, for real, for real, for real. Ask your questions to your group, ask your questions to me. Sometimes it's nicer to hear someone your age explain it. Sometimes it's nicer to hear me say it. But ask your questions before the test. We're going to start learning how to study really well for high school, and that means looking at the information so that you know what you're confused about before you get to the test, and having time to actually ask those questions to people. All right, I'll see you in class.